So yesterday you started looking at how you could use the opposites of binomials when you are factoring polynomials. So just a quick review of what you looked at yesterday. To find the opposite of a binomial, that means just multiply it by -1. So in this example here, if you want to know the opposite of -3, that means multiply -1 by x minus 3. And when you distribute the -1, you get -x plus 3. And then if you use the the commutative property of addition, you can switch this and it becomes 3 plus -x, which simplifies to 3 minus x. So 3 minus x and x minus 3 are opposites. Another example, x minus 10 and 10 minus x are opposites. So we can use this fact to factor binomials. So let's just look at the 4 questions that you worked on yesterday and see if this makes sense. So if we want to factor this, first thing we notice is we have 4 terms, and if we see a polynomial with 4 terms, we should automatically think use grouping. Right? So first thing I'm going to do is I'm going to group together those 2 terms and think about factoring each of those binomials. So if I look at 15x squared minus 10x to the third, the greatest common factor of 15 and 10 is 5. The greatest common factor of x squared and x to the third is x squared. So that's what goes outside the parentheses. And so if we take 5x squared out of 15x squared, we're left with 3. And then we've got minus. And if you take 5 out of 10, you still have a factor of 2. And if you take x squared out of x to the third, you still have a factor of x. So that first binomial factors into this. And now we want to factor the second binomial. Well, looking at 8 and 12, the greatest common factor of those would be 4. There's no factor of x over here, so 4 is your GCF. 4 times 2x gives you 8x minus 4 times 3, which gives you 12. So now you have factored it into 2 separate expressions. So looking at the 3 minus 2x and the 2x minus 3, those binomials are not the same. But you should notice that they are opposites. So we can use what we know about opposites to rewrite one of these to make it match the other. I'm just going to think about how can I rewrite 2x minus 3. Well, I can multiply -1 by the opposite of 2x minus 3, and that's going to be the same as 2x minus 3. So here, 5x squared, this is all going to stay the same. And then I've got the 4, but instead of writing 2x minus 3, I want to write it as -1 times the opposite. So I'm going to write the -1 and the -1 times the opposite of this, which is going to be 3 minus 2x. So that right there is just another way of writing 2x minus 3. -1 times the opposite will give us 2x minus 3. So now we notice we have common factors of that binomial 3 minus 2x. So we can take that out, and that's just like you were doing before in the last few days. We've got the 3 minus 2x, and then what we have left here is 5x squared, and here we have plus 4 times -1, which gives you minus 4. So that is your factorization of this polynomial that you started with. All right? Let's look at number 20. Now, we didn't talk about this before, but when you're looking at these polynomials with 4 terms, one thing to pay attention to is this sign here in the middle. All right? If I were to just group this and this, that minus now suddenly goes with everything in the parentheses. But the way that it's originally written, that that negative or minus sign is only with the x. So I can't put parentheses around x plus xy because that minus doesn't go with the xy. So if you ever see a minus right here in the middle, before you start putting parentheses around both sides, you should rewrite that minus as plus negative. And that way, so instead of writing minus x, I'm going to write plus negative x. And now we just have that minus with the x. And now we can put parentheses around this. And then the plus xy stays the same. So all I did was change minus x to plus negative x. Now I can group this, and then I can group that, and now the negative only goes with the x. So now we're ready to factor each of these. The greatest common factor of this first binomial is 8, and so you're left with 8 times y minus 8 times what is 8? You've got to put the 1 there. Alright, so there's your factorization of the first binomial. And now we have plus, and now look at the common factors of negative x and plus xy. They both have a common factor of x. So when you take out the x, what are you left with here? X times what is negative x? Well, all it is negative 1. X times negative 1 gives you the negative x. And now for the second term, x times y is xy. Well, got negative 1 plus y. What do you notice here? I'm just going to leave the y minus 1 here and the x. Hopefully you agree that negative 1 plus y is the same as y plus negative 1, just using the commutative property of addition, and I can change y plus negative 1 to y minus 1. So what do you notice on this? We already have the exact same binomials, so in this one we don't have to do anything with opposites because we already have the same factor binomials. So I'm going to factor y minus 1, and what does that leave us with? That leaves us with the factor of 8 here, and here it leaves us with x. So there's our answer on that one. Alright, what about 21? So looking at this, what do you notice immediately? Hopefully you notice you have a minus right here between the two different binomials, so I want to change that to plus so that I can then group it. So I'm going to start by rewriting this as 48n to the 6th. I'm going to rewrite this as plus negative 56n, and then we have the plus 21. So now we can group it. The first two terms go together, the second two terms go together. Now the greatest common factor of this term, looking at 48 and 18, you would agree that 6 is the greatest common factor of 48 and 18, and then looking at n to the 6th and n to the 5th, n to the 5th is the greatest common factor, and what do we have left? 6 times 8 is 48, n to the 5th times one more factor of n, and then for the second term, 6 times 3 is 18, n to the 5th times n to the 5th. I don't have any more factors of n that I need, so there's our factorization. And now for the second, 56 and 21 have a common factor of 7. I don't have an n with the 21, so that's our greatest common factor. And inside we have 7 times negative 8n would give us negative 56, and then 7 times 3 gives us 21. So again, I'm thinking, what if I rewrite this using the commutative property? Negative 8n plus 3 is the same as 3 plus negative 8n, which is the same as 3 minus 8n. So what do we notice? 3 minus 8n and 8n minus 3, those are opposites. So that tells me that I want to rewrite this as the product of negative 1 and its opposite to make these two binomials look the same. So 6n to the fifth times 8n minus 3. Now for the second term, I'm going to write 7 times negative 1. Well, now I'm looking at this right here. Right, so this is what we did. So I want to take the opposite of that, and that becomes 8n minus 3. Alright, so now we have matching binomials, so we can factor that out. So the 8n minus 3, and then the other product we have is 6n to the fifth, and then plus 7 times negative 1 is negative 7, so we write that as negative 7, and there's our answer for it. And then for the last one, we have here, again, notice we've got a minus in between the two binomials, so the first thing I want to do is just change this to plus negative 3t, so it becomes 8t to the fourth. I'm going to write plus negative 3t. Now we can group these, factor each. 8 and 48 have a GCF of 8, t to the fourth, t to the third. T to the third is a GCF, so that goes outside. Well, we need one more factor of t to make 8t to the fourth, and then 8 times 6 is 48. T to the third times 1 is t to the third, so we don't need to add any more factors of t. Now looking at negative 3t and plus 18, we could factor out 3. Now some of you may have noticed already on the others, instead of factoring out 3, what if you factored out negative 3? That might save you a few steps, so think about that. If you factored out negative 3 and you don't have any factors of t, think negative 3 times t would give you the negative 3t, right? Well, now think, what do you have to multiply by negative 3 to get plus 18? Hopefully you agree that that would be negative 6, because negative 3 times negative 6 gives you positive 18. So by going ahead and factoring out that negative, what do you notice now about the binomials? They already match. If you would have factored out a positive 3 right here, if you would have made this positive 3 right here, that would have been 3 times negative t plus 6, which would be the same as 3 times 6 minus t. And do you see then that you would have had 6 minus t and t minus 6? Those would have been opposites, so that you then would have had to have multiplied negative 1 by the opposite, which would take you to here. So by factoring out the negative 3 right there, saves you a few steps. Either way, it's perfectly fine. So now you've got t minus 6 in both. All you're left with here is 8t to the third, and you have minus 3 right there. That's your answer. So hopefully that helps make a little bit more sense of working with these binomials where you are factoring out opposites.